So here's part C from number 1 on the 2012 AB and BC exam, and they want us for the interval from 0 to 20 to recognize that the average temperature of the water in the tub is indicated by this. So this is just a formula that you're probably familiar with for the average value of a function, which is just a definite integral across the appropriate limits of integration divided by the difference between the limits of integration. But it wants us to use a left Riemann sum for subintervals as indicated by the data in the table to approximate this. Does this approximation overestimate or underestimate the average temperature of water over these 20 minutes? Explain your reasoning. So what I've already done here is I took a minute before I started the video recording to just kind of quickly plot these points in the coordinate plane. And if we're doing a left Riemann sum using intervals indicated by the data in the table, our first subinterval is going to go from 0 to 4. And then the left endpoint of that subinterval, if we're doing a left Riemann sum, the left endpoint is 0. And a left endpoint Riemann sum is simply going to mean we're going to use the value of the function at the left endpoint of that subinterval to generate the height of our first rectangle. So the first rectangle for our left Riemann sum would look something like that. Now our second rectangle has a slightly bigger width, right? The width of this subinterval would be 4, the width of this subinterval would be 5. Left endpoint is 4. We're going to use the function value at 4 to estimate the height, or to give the height of the rectangle there. And then at 9, we're going to use the function value, which I kind of got off a little bit with there. We're going to use the left endpoint of this subinterval at 9 to give the height of this next rectangle. And then our last subinterval goes from 15 to 20. Left endpoint's 15, so we're going to use the function value at 15 for the height of that last rectangle. So we would need to add together the areas of these 4 rectangles in order to appropriately estimate this with a left Riemann sum. So I'm going to say that the value of this definite integral is approximated by the area of this rectangle plus the area of this one plus the area of this one plus the area of this one. Well, the area of this rectangle is going to be the width of it, which is 4, times the height, which is given by f of 0, which is 55, plus the area of this one, which has a width of 5, and a height given by w of 4, and w of 4 is 57.1. We can just take that right out of the table. The width of the next rectangle is 6 units, and the height of that is given by w of 9, which is 61.8. And then the width of our last rectangle is back to a width of 5 from 15 to 20. And then the height of that rectangle is given by the function value at 15, which is 67.9. So this is a calculator problem. You'd definitely be able to evaluate this on your calculator pretty quickly. Now what we would have to do with that answer is we'd have to remember that we have to divide it by 20 or multiply it by 1/20th in order to turn it into an average value of a function calculation. So I'm going to get my calculator going here and take a minute to evaluate this, and then we'll get back and we'll discuss the second part of this problem. So I just took a minute to evaluate this on the calculator, and I got this 1215 value, and then I multiplied it by 1/20th or divided it by 20, and I end up with an approximation for this average temperature of the water of 60.79, and that would be measured in degrees Fahrenheit. It's the average temperature of the water. Kind of makes sense. I mean, look, you've got values below that, you've got values above that, so average has to be somewhere in the middle, so that seems legitimate. The only other thing that we want to do here is decide whether or not this is an overestimate or an underestimate for this value. Well, we're going to have to think about the Riemann sum in order to answer that question. Now, I plotted these points on the graph. Since this graph is an increasing graph, it's not going to be a linear function. It's going to be something that looks a little bit different. But they do tell us that it's an increasing function. It's always increasing. If we have an increasing function, check out what happens with every single one of the rectangles that we placed beneath the curve there. The exact value of this integral right here is going to be the exact signed area between the t-axis and the function. These rectangles don't account for this area, this area, this area, or this area. So we're losing a considerable amount of area that we were supposed to account for when evaluating this integral. So although we have a pretty nice estimate, it's definitely going to be an underestimate because we've lost all this area because our left Riemann sum placed all these rectangles beneath the increasing curve or the increasing function, And so our estimate is definitely an underestimate.